Hey folks, Eric Wooldridge here with the Additive Guru channel. I'm going to take a little time to talk about Infill, the benefits, the features, and those kind of things that you need for typical FDM applications. So here we're taking a look at Cura, and in Cura we have a simple little calibration cube. You can download one of these things from Thingiverse or any other kind of repository, 20 by 20. And the cube is solid, and we're going to take a look at our slicer settings that you see here, but we're going to switch to custom. And we're going to take a look at specifically of our list of options here. We're going to take a look at the infill. And you'll notice with the infill we have some options in terms of percentage and also infill pattern. And right off the bat, the 20%, most people understand this in basic 3D printing, that this is the percentage of space that the infill is taking up. The higher percentage, the denser the infill, and the longer it essentially takes to make it. Infill is essentially used to leave parts of the object a little bit more hollow. So if we're looking at a cross section of our cube and it's making the bottom there and the outside walls and the top wall, the infill is in this zone here, which is taking up space that may not be structurally necessary. And it may be in patterns of zigzags, honeycombs, or what have you. So the purpose is to not waste material where it's not needed, but also it's to support the underside of the top layers so they don't sag. For example, if again we're looking at a cross section, and I've built up the bottom layer, the side walls here, and I do a very low infill, 5–10%, then there's a chance that as this builds up, there's too much space in between the support points, and you get a top layer that ends up sagging because there's not enough support underneath. So the infill doesn't only just take up space, but it also provides a support, a gravity support if you will, for the top layers of the object. So let's take a look at my cube that I have, and let's tell it to slice. Okay, preview, and I'll drag it down, we can see it. And you can see with this particular design and a 20% cubic infill, you have a infill pattern that kind of looks like that. If I switch it to 10% and then slice, you see that the infill is taking up much less space than it was. Let's take a look at 50%. A much denser pattern. We go all the way to 100%. And it actually makes it completely solid, one layer after the other. Let's see what 99% looks like. Yeah, pretty close. How about 80? Alright, so you can see little gaps in there too. So one of the things to understand is that the infill has a lot of power and a lot of options. And typically most infills in slicing applications, we don't get around, we don't start doing a lot of 100%. We take it down to smaller values. And you'll notice in particular with Cura, you have a lot of options. There is the lines, which is a typical sort of X pattern, if you will, one direction versus the next. There's also triangles, trihex, octet. That you can see there. And so you may wonder, what's the one advantage of one design versus the other? And there are a lot of different opinions about that. There is plenty of case studies out there to talk about different values of strength and performance based on your pattern of infill. One study that we saw did see that rectilinear, or basically lines, which would probably be equivalent to lines here, did have a slightly better strength performance than the others. This particular design, this octet, seems to have a very interesting pattern system that goes in different directions, which is pretty interesting. Then there is the gyroid, which is also very interesting, that we've seen some very interesting results in terms of overall product performance. The squiggle that you see there. So you can get a lot of results in terms of your infill, and you can also eat up a lot of time in terms of your infill based on your settings and the type. So you get to choose yourself as the designer and the technician and fabricator what infill you're going to use to take up the space and what percentage. And just understand this, it may be great in your mind to actually make a completely solid object, but that eats up a lot of time and you may not be getting any real strength value out of the performance. Again, for most applications, most designers will run somewhere between the 20, maybe 30% infill, and the patterns that they choose will vary. And we're actually, the concentrics one we've seen done too, where it's creating patterns of lines all the way around with no support from one structure to the next. Notice that these lines of infill don't make contact with that. Now we're not going to get into the true science of all this. What we do want to focus on is the basics. So one of the things, as I mentioned, you want to watch out for your gaps between infill points, because as this thing reaches the top of your object, your top walls, your top shells have to have a support point. And if I take this down to, let's say, 2% infill and concentric, you can, well, actually that's nothing at all. Let's try 10%. As I get near the top, there will be a gap between this point and this point, and the top layer is probably going to sag down. So even though this simulation makes it look like it's going to be nice and solid across, more than likely it's not. So it's one of those things you want to watch out for in your design, is that you don't go so low that you have top objects that sag. Now, if you had an object that was printed, like if this is the build plate and we're printing up into like a cone point like that, then it wouldn't really matter how dense your infill was, because at the top it was coming together at a point, so it wasn't a big deal if it was spread far apart. You get to make the decision, but you always want to consider how much material you're using and how much time it's going to take to actually produce it in exchange for having that nice supported surface. Now again, one other thing to realize is that when it comes to primary stress, especially objects that are, for example, a beam or something, if you're pushing down on this, the stress is going to be near the tops and the bottom of the object, not in the center. So for most parts, your strength is in these values of your shells, not so much of your raw infill, unless we're talking about just pure compression. So for most of your applications, you want to think about 10, maybe 20, you want to think of really about 20 to 30% of your general infill, and your pattern to be something of strength. We can choose the lines. Looks like I am curious on the performance of the octet here, because that's one we haven't tested before. And the whole vertical transition, as you see, it kind of flares up and down in almost a three-dimensional type of infill, which we think is pretty interesting. The gyroid, though, we are seeing some interesting results on that, so that's worthy of some further review, because we can definitely probably see some advantage in terms of structural performance by that wavy pattern. So anyway, great stuff to think about and to try out. As far as your application with this, remember, just keep your infill settings where it's reasonable, and by increasing it to 67%, 60 or 70%, you may not get a super big benefit out of that. Now, if you are doing something where it is sort of composite material, or you're doing a sintering process, maybe you're using material that has embedded metal, then you might actually have to go to a pure 100% infill, because the material is going to require that for its actual processing, and so then you don't have a whole lot of choices. Keep that in mind as well. Alright, so that's all we have for this time. Hopefully that it gives you a good feel for it. Set the values that work well for you. Know that unless you have specific applications, 20 or 30% is probably going to do it. And experiment with the different types of infill as you go along. Most people, if a good person, technician is actually working on this, they'll never know what type of infill is used, because their strength is really going to be about how many shell counts they have. Alright, thanks for watching, and check out some of our other videos. You might find something pretty useful. We'll see you.